Hi everybody, this is my artificial intelligence course final project. This project is a web-based game design using artificial intelligence techniques. The application finally completed is a reactive and rule-based system that knows how to play Tetris by itself and relatively optimal. So I'm gonna do a quick demo. Right now, it's at horse speed. As you can see, right now the agent is playing Tetris by itself. The rows are removed. Um, Now I'm gonna switch that to a faster speed. Okay, so it's much faster now. It's actually playing 10 times per second, so you can barely see what's going on now, but you can get a general idea that the artificial intelligence algorithm is working behind it. The rules are removed, and also you can see the score on top. The score is increasing. That is the rows removed by the agent. So the technique behind it is actually every time when the computer agent gets a random piece, it evaluates all the possible placements, including orientation and location, and then it finds out the best placement, which is going to lead the best consequence, potentially more number of rows removed. So as this thing runs, I'm going to explain the theory behind this real quick. Um, to be specific, how it's done. So we first define a fitness function with 6 features, such as rows will be removed by taking the move. Uh, what's the height of the highest block in the space? Then the computer uses function every time when it evaluates a move. On the other hand, there's a weight for each of these features because some of them may be considered more, some of them may weigh less. Just like you may think rows will be removed is the most important factor. So in order to get the relatively optimized weights, we use particle swarm optimization to train the weights, to optimize the weights to get the relatively best weights. As you can see, I just started training our weights. So the computer keeps playing the game over and over again, adjusting the parameters to the relatively optimal parameter. So eventually, this thing is going to converge, and we will get a relatively best weights to make the computer score the most. So this just started. It actually takes us half day to get the relatively optimal weights. So I'm not going to let it go. Instead, I will show you the actual data we collected when uh, when we did our training. So as you can see, it starts from like 1,000 with these weights, random weights, and then so adjust these weights, and then we can score higher, like 3,000, and then 5,000. Just keep increasing. So eventually, this thing converges. We can achieve something. We can achieve somewhere around 24,000 with these parameters. So this is our relatively best parameters. And then we use these parameters for our 6 features. And then to uh, make the computer act smartly. The game actually supports 2 modes. The first one, AI show, which AI plays to show how much it can score, plays it Tetris by itself. The second mode is called game playing computation mode. It's basically the user plays Tetris game to compete against the computer agent. As you can see, I'm actually doing it right now. I'm playing on the right side, the right window. It's me on the right side, and then the computer agent is on the left. So we are playing against each other, and then see whose score is higher. Basically, we both get same piece each round, but I have to make the move first before the agent makes the move, so that I don't cheat. And then you can see the score on top, the AI score and player score. Basically, the rows removed. Yeah. Also, where I'm actually see the difficulty level. This is arcade mode. Um, so what happened is at certain level when I remove some of the rows, some rows, there will be random blocks appeared generated on the left window on the agent side. As you can see right now, my side, there are some gray blocks generated because the agent removed some rows, so there are random blocks generated on my side. The computer is actually really smart. We have trained the computer to be able to score over 50,000, but for human instead, we can typically only score somewhere around 100. As you can see, this computer is much more smarter than human, and that's what the whole idea about this thing. The artificial intelligence part makes the computer really smart, even smarter than human. Yeah, that's pretty much it. Thank you. Thanks for watching.